In 5th grade, we asked students to divide a whole number by a unit fraction. A unit fraction is a fraction with 1 as the numerator, as in 1/3. So, when we look at 3 divided by 1/3, I like to connect it to a whole number division. So one way of looking at this is 3 divided by 1/3. And then we could subtract out 1/3. We could actually subtract out 3/3, which is 1 whole, and get 2. And they can see, okay, I subtracted out 3 groups of 1/3, and we can continue this process. We can subtract out another 1, which is 3 times 1/3. And then they get 1. And then we can subtract this out to 0, which is another 3 times 1/3. And we can see here that 3... How many groups of 1/3 did we subtract out? We subtracted out 3, 6, 9. So 3 divided by 1/3 is 9. And that's our answer. A lot of kids like to do it that way because they like to make that connection to whole numbers. I find, though, that even if they do like this way over here, it's very helpful for the entire class, especially the ones that are kind of like, huh, over here? I get the, I'm not sure about that, is to just show them the model, what we're doing. So I can draw out 3 whole, and I'll represent that with 3 rectangles. There's each rectangle is a 1 whole. I'm going to split them into thirds. So there, there, and there. So the question now is, okay, I have my 3 whole. 1, 2, 3. I've divided them into thirds, and I just count how many thirds did I create. How many groups of 1/3 do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. There is 9 1/3 and 3 whole. So how many groups of 1/3 can you create? 9. And we can check our work, which is really big here, division. 9 times 1/3 should equal 3 if we have the right answer. So 9 times 1/3 is 9/3, which is the same thing as 3. So ding, 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 we have the right answer. Let's look at one more. Now I purposely picked this one because there's such a huge misconception here. And every year, 4 divided by 1/2, they want to say 2. And I have to come around and say, no. Nope, sorry. Sad face. And it crushes their spirits, and they shake. They look at me like I'm crazy and rub their head and try to wonder, what did I do wrong? Well, what they're doing is, okay, they think this is asking what is half of 4. So they're thinking, what is half of 4? And I point out to them, half of 4 is the same thing as 1/2 times 4. And that is not the same problem here. This is 4 divided by 1/2. This is not 1/2 times 4. And they're like, oh, okay, so getting them to defeat that misconception, and again, you can model it so they can see we're making groups of 1/2. How many groups of 1/2 are in 4? We can count these up. I have 4 whole, 4 rectangles, and I'm going to count up the halves. 1, 2, 3, 4, 5, 6, 7, 8. So 4 divided by 1/2 is 8. Or another way I like to, some students like to do it, I definitely show them because it builds up what we learned. 4 divided by 1/2, and they can just subtract out 1/2 repeatedly, and they can say, okay, that I took 1/2 and times it by 1, so they can keep track of how many 1/2 they're doing, or they can start getting crazy and subtracting out 1 at a time. And as they continue down this process, they will again add up all the halves that they subtracted out. Wrong one there. They're going to add up all the halves that they subtracted out, and that would be on this side. So they'd add it up, which I'm not going to go ahead and do. But they would count up, and if they did it correctly, they get an answer of 8. So either way it works, the traditional division, the modeling, whatever method they choose, I do want them to go back and check their work, and they do that by taking their answer and multiplying it. So they take their quotient, multiply it by their dividend, and it should equal their quotient, multiply it by their divisor, and it should equal the dividend. 8 times 1/2, or 1/2 of 8, is 4. So we know that this is the correct answer.